We are moving on to the next lesson, which is 11.2, adding integers. And example 1 is adding integers with the same sign. And this might seem super easy at first, but it does become a little bit harder when you've got, larger numbers. So I know that you know that 3 plus 4 equals 7. This is something you learned a long time ago, but I want to show you an example of how I usually teach this or start to teach this in the classroom. So I usually use counting chips, like it's yellow on one side and red on the other. So the red side, that's what the R stands for, that would be your negative, because usually if we describe something as like in the red, it's not a good thing, it's a negative thing. And then our yellows are going to be our positive numbers. Let me see if I can color these in too. Let's try. Okay, here we go. We've got, oh good, I covered up the Y. That's exactly what I was not wanting to do. I will write over them. Here we go. We've got an R here and a Y here. So if you have red and yellow colors at home with crayons or colored pencils, it might be helpful to get them out. So pause this video if you want to go try to find them. Otherwise, you can just use the letter R and the letter Y. But it is sometimes easier to have like a visual representation. So here's how I would start teaching this in the classroom. We have all positive numbers in example A. So we've got 1, 2, 3. They should be yellow. They should be yellow. Here we go. Oh, goodness. All right, redo. 1, 2, 3, because they're all positive. And we've got 4 more. 1, 2, 3, 4. So altogether, we would have 7, obviously. 1, 2, 3, 4, 5, 6, 7. That's how we get a positive 7 as our answer. So now let me show you what it would look like when we have negatives. So let's say example B, we have negative 3 plus a negative 7. And you'll see that the negative 7 is in parentheses, and that's just to kind of separate the signs. And so I meant to make that a 4. Let's make it a 4. Sorry, guys. Okay, here we go. So we've got negative 3 plus a negative 4. So this time you would have 3 reds because reds are negative. And then you would have 4 more reds. And so you would have a total of 7 reds. Which means that your answer here would be a negative 7 because reds are negative. So I am going to try a few of these examples, I think, without the colors, because I'm not trying to confuse you either. So let me clear my screen. If you need to, you can back up. We'll make this example C. So let's say I have negative 2 plus a negative 3. Without the colors, this would be negative 5. Basically 2 reds, 3 more reds, a total of 5 reds. What if we have negative 6 plus a negative 3? Again, 6 reds, 3 more reds, a total of 9 reds, so it would be negative 9. 1 more D, E. And again, same signs means you've got 2 negatives or 2 positives. So if we've got 2 positives, like 2 plus 7, I know you know that's a positive 9. So I guess it's really just when the negatives are thrown in that we might get confused a little bit. So here, one more. One more. You love it when I do that, right? Let's say we have negative 12 plus a negative 4. They're all negatives. They're all reds. It would be a negative 16. I think the confusing part comes in when some of the numbers are positive and some of the numbers are negative. So I'm going to clear my screen. EX2 would be adding integers with different signs. And I think this is where the counters really do come in handy, and I'll show you. This particular problem, let's say we've got 4 plus a negative 7. So this is different than the other example problems because your 4 is positive and your 7 is negative. So if we were using counters, you would have 4 yellow and you'd have 7 red. Now, if you have a positive and a negative, they end up canceling out. It's like if you have $1 and I take $1 away from you, you have nothing. And so this yellow would cancel with this red. This yellow would cancel with this red. This yellow would cancel with this red. And finally, this yellow would cancel with this red. So you're left with 3 reds. Remember, reds are negative. And so your final answer for this problem is going to be a -3. There are 3 reds left over, -3. Let me see if I can show you with another example with some smaller numbers. How about -2 plus 5? So if we are using colors to represent, we have 2 reds, those are our negatives, and we've got 5 yellows. And we want to cancel the ones that match up. So a -1 and a +1, that would cancel and make 0. A -1, a +1, that would cancel and make 0. This time you have 3 yellows left over, so it would be a +3. Let's do one more on this page. How about, good one, -4 plus 4. So we've got 4 reds, and we've got 4 yellows. And if we start canceling out, that pair cancels, that pair cancels, oops, I skipped one, that pair cancels, and finally this pair cancels. You would be left with no counters left, so you would be left with 0. I think I'm going to stop this video there. I'm also going to try to find some videos with some other explanations on it. But we'll start there and see how it goes. Thanks, guys.